Hello students, today we are going to explain about full wave rectifier. In the previous session, we studied about the half wave rectifier. In half wave rectifier, we use single diode and the transformer is step down transformer. Whereas in full wave rectifier, we use two diodes and we use a center tapped transformer. So first, we are going to explain about the meaning of rectifier, the definition of rectifier. Rectifier is an electrical device or circuit which converts alternating current to direct current, or bidirectional signal is converted as unidirectional signal. Now coming to circuit diagram of full wave rectifier. Okay, so here a rectifier input is AC signal. AC signal means a bidirectional signal. So positive half, positive amplitude as Vm, negative amplitude as minus Vm. And we got the output across the RL. So through this RL, we got the output like this. Right. So here input bidirectional signal AC input is giving to the step down transformer. Step down transformer. So here AC input is a high voltage signal. If this high voltage signal is giving to diodes directly, then these two diodes are going to be damage condition. So to avoid that condition, we use the transformer. Okay, so here transformer is a convert high voltage signal to low voltage signal, and here we use a center tapped transformer. Center tapped transformer means so this is a primary winding. For this primary winding, we are giving the AC input, and the secondary winding is giving to two diodes. Two diodes. So center tapped means this voltage is shared by secondary winding for these two diodes equally. Right. So we know the function of diodes. Function of diode is allows the current in single direction. During positive half cycle, diode is going to be on. During negative half, diode is going to be off condition. Two anodes are connected to secondary winding of the transformer, and the cathodes, these two cathodes are connecting together at one point. Right. So these diodes cathode connections are given to load resistor. So from this load resistor, we are taking the output. This is the total circuit explanation of a full wave rectifier. Now these two are the input waveform and output waveform. We know the input waveform is AC input bidirectional signal. So here AC means alternating current, always changing with respect to alternating current or alternating voltage with always changing with respect to time period. So that is why on x-axis we are representing time period omega t, and on y-axis voltage. So positive amplitude is Vm, negative amplitude is minus Vm. Okay, this is the input we are giving to here primary winding of the center tapped transformer. 230 volts, very high amount of voltage. So this transformer converts that high voltage into low voltage and then give it to these two diodes. So here these two diodes are connected in a parallel connection, which means if D1 is in on condition, obviously D2 goes to off condition. If D2 is in on condition, D1 is goes to on condition, like that. So totally we are taking the output through across this RL load resistor. So we are getting this kind of output. Okay, right. So coming to this waveform, so from 0 to pi, input is at positive side. So during positive half cycle, what happened in the circuit diagram? During positive half cycle from 0 to pi, so input signal is the positive signal. Input signal is the positive signal. So in this situation, diode D1 goes to on condition. Means diode goes to forward bias condition. So this diode acts like a closed switch. So during positive half cycle, diode D1 goes to on condition, which means it is going to be forward biasing condition, acts like a closed switch. At the same time, diode D2 goes to off condition, means this diode is going to be reverse bias condition. So in this situation, diode D2 acts like a open switch. Open switch. So D1 is in on, D2 is in off. From these two diodes, even one diode is in on condition, then we get the output. So from these two diodes, now D1 is in on condition, right? So if D1 is a forward bias condition, so obviously we are getting the output across this RL. So that is why from 0 to pi we are getting the output like this. So from 0 to pi, D1 is in on condition, D2 is in off condition, right? So 0 to pi, positive half completed. Next, then go for second half, that is from pi to 2 pi. Pi to 2 pi, input is at negative side, negative signal. Okay. So if negative signal is giving to here, then what happened diode D1? What is the function of diode D1 and D2 now explain. So this negative signal is giving to here. So in this situation, diode D1 goes to off condition, means D1 is going to be reverse bias condition, means D1 is acts like a open switch. At the same time, D2 goes to on condition. On condition means D2 is in a forward bias condition. So here D2 is acts like a closed switch. From these two diodes, even one diode is in on condition, then we can get the output. So we got output from D2 now, and the output is pi to 2 pi. We are getting like this. Why we got the output is at again positive side? We expected the output is at a negative side, right? Why we are getting at positive side? Why? Because first output is a positive side, right? First output is at positive side. We already know about diode. Diode accept the current or accept the voltage in single direction. Okay, so that is why 0 to pi, this is a positive signal. So that is why same thing. In same direction, it accept the output. It can accept the output. So pi to 2 pi. So same thing at positive side, we are getting the output. So pi to 2 pi, D2 is in on condition, D1 is a off condition. Next, 2 pi to 3 pi. 2 pi to 3 pi is a positive peak, positive signal. Again same, if a positive signal is giving to the full wave rectifier, then diode D1 goes to on, goes to forward bias condition, acts like a closed switch. Next, obviously if it is in on condition, obviously D2 is going to be off condition. Off means operated in reverse bias condition, acts like a open switch. So from these two diodes, even one diode is in on condition, then we can get the output. That output is from D1 now. Okay, so 2 pi to 3 pi also we are getting the output, that is at a positive peak only. Why? Because first peak is positive peak. So in that positive side only we are getting the output. Why? Because diodes accept the current or voltage in single way, single direction. So 2 pi to 3 pi, D1 is in on condition, D2 is in off condition. So these are the input and output waveforms of a full wave rectifier. Full wave rectifier uses positive peak, negative peak, entire cycle of the input signal. So we got the output at a positive peak, as well as we got the output from negative peak. So full wave rectifier uses entire cycle of the AC input. The output voltage equations, V naught equals to 2 Vm by 2 Vm sin omega t. 2 Vm sin omega t from 0 less than omega t less than 2 pi. Right? Why I am taking 2 Vm sin omega t? From 0 to pi we got the output, and from pi to 2 pi we got the output, that is Vm sin omega t plus Vm sin omega t, that is equals to 2 Vm sin omega t. This is a output voltage current equation, and the output current equation is a 2 Im. Similarly, output current equation is a 2 Im sin omega t. The limits are from 0 to 2 pi. Right? So this is the operation of full wave rectifier and the output equations, output voltage and output current equations. Thank you.